Hello everyone, I'm Natapol Homglan, and today I'm with Chanrutaya Sothon. We are going to talk about some interesting questions about neutrinos. So let's start with the first question. What does it mean in Italian? In Italian, neutrino means little neutral one. It comes from a prefix neutrale, which means neutral, and a suffix ino, which means small. And why is it very hard to detect in 1930 to 1950? The first reason is its lack of electric charge. Neutrinos do not experience the electromagnetic force or cause ionization of matter. The second reason is its extremely weak interaction with other particles. So the interaction force will be very short range and result in an extremely low probability of interaction. The third reason is because of their extremely low or possibly zero mass. And the last reason is its ghostly nature, because a typical neutrino can pass through an enormous amount of matter, for example, a light year of length, without interacting. So how does Poltergeist project detect neutrino? They use a reaction called inverse beta decay, which they put in a high amount of antineutrino flux to create a neutron and positron, which neutron and positron will produce two bursts of gamma ray, and they detect the two gamma ray to validate the theory. So where is the location of the experiment? The detection tank is buried deep under the reactor, about 11 meters, and it is at the Swana River plant in South Carolina, USA. And what is the advantage of this place? So this place is a well-shielded location which will minimize background noises from cosmic rays and other sources. Another interesting question is how do stars generate neutrino? So star is like a nuclear reactor which they use nuclear fusion to produce neutrinos. For example, the sun. The sun will use proton-proton fusion to produce neutrino by using its heat and pressure of its core to fuse two protons into a deuteron, which will result in neutrino and positron as the product.
The study of neutrino began when Leigh Davis and his colleagues detect neutrino from the sun by using a giant tank filled with kaolin placed deep underground in the Homestake Gold Mine. When the solar neutrino interact with the kaolin atom, it changes kaolin into radioactive argon atoms. Because argon is a noble gas, Davis could collect and count the argon atom. Even though only about 10 to 20 atoms per month were detected, this was enough to prove that neutrinos from the sun really exist. However, Davis discovered something unexpected, and the number of solar neutrinos he detected was only about one-third of what theory predicted. This surprising result became known as the solar neutrino problem. Scientists were unsure whether the problem came from the experiments of solar theory or the neutrinos themselves. To study neutrinos in a different way, this place is called Homestake Gold Mine, where the most experiment was done, and is where the solar neutrino problem was first discovered. Later, scientists built a Cheminokente detector in Japan. It detects neutrinos using a large tank of pure water. When a neutrino interacts with an atom in water, it produces a charged particle, such as electron or muon. This particle travels faster than light in water and emits Cherenkov light, which is detected almost instantly by sensitive light sensor called photomultiplier tubes. By using this upgrade detector, superkaminokinase researchers made a major discovery and got Nobel Prize. They found out that the neutrinos actually have mass. But what about the supporting evidence? From the superkaminokinase detector, they found that the number of muon neutrino detected was smaller than expected. The missing amount depended on the distance the neutrino traveled. And from the late Lewis experiment, as I mentioned before, he detected far fewer solar neutrino than predicted by Thiele, about 3 times fewer than expected, which caused the solar neutrino problems. These observations lead to the discovery of neutrino oscillation, which means that neutrino can change from one type to another as they travel. This discovery was extremely important because neutrino oscillation can only happen if neutrinos have mass. So they got Nobel Prize. And thank you for your attention.